Hello, YouTube viewers. Welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about a very important conceptual topic. It is moonshots versus our current technology. Meaning, because we are running out of time, we have to make a decision. Do we want to invest in technologies that we already have, or do we wait for some, quote unquote, silver bullet or magic bullet, so to say? Because time is running out. It's here. It's real. Almost everybody is kind of understanding. It's like we can't keep doing this because this does start to have an issue. This really makes your plate of food become ludicrously expensive. So it's something that is broken, and we have to fix it, and we have to fix it now. We do not have any, luxury of time left. We spent all that. So that part is taken care of. We have to do now. So that's one thing. And we do not have any perfect tool. That's a fundamental limitation. Do we have tools to take care of this situation? Absolutely. We got this. We're solid. We're good. But do we have one singular tool that's deploy this tool, humanity takes care of it, everything else? No, we do not have that. That's the fundamental issue. So many times people are looking for spending money, time, effort on moonshots, meaning if this works out, it takes care of all our problem. So those sort of projects are like, taking some serious effort, money, all that. So because one thing you have to understand, time does not come back. Even if you somehow magically your economy grows ludicrously large, you find some like freaking giant gold reserves and all that jazz, you still cannot buy back time. So time is one thing that you must be wise with its expenditure and effort. Many times if people get burned from bad projects or like bad solar investment and all that jazz, it backfires, and it has serious consequences where people will like, you know what, I do not want to work in that. I do not want to work towards the solution. So it is serious, it is real, it is here, it's a problem that we have to face. Do we invest in moonshots, or do we deal with what we have right now? So what do we have right now, like in terms of major big boys? So big boys, the big boy number one is solar. Now solar, thankfully, in case of majority of places that are close to equator, it works. It's one of those scenarios where it's like it just works. Shut up and take my money. It works in India, it works in Australia, majority of Africa, it works without any issue. You just shut up, give its money, and it's done, taken care of. Like, don't think too much about it. That part is awesome. Like in these sort of places is already cheaper than coal. So this puppy works awesome. But it does have issue, meaning it is still location limited, meaning the same solar farm that will work GG in India will not work GG in Canada. Even you may have to give it like 3 or 4 times the surface area in order to get the same amount of actual power use. So there are some limitation in terms of its location. On top of that, it needs ludicrously large energy storage, because it, at best case scenario, it will only work for 6 hours. That's not enough hours in the day. Basically, like enough hours in the day would be like 24. This is only works for 6. That means you have to overproduce by like 3x or 4x, and you have to store that. That means the amount of energy storage you require is ludicrously huge. It's not little bit, it's huge amount of energy storage you have to do. Otherwise, it will simply not work for our current system. So that's fundamental limitation. And what about wind? Now, wind is also second green technology that has got the benefit of economical benefit, meaning it makes sense to do. So solar, why solar is growing so much? Because it makes economical sense to do. Same with wind, it makes economical sense to do. Now, it works almost 24/7. Now, be mindful, its output will not be constant. If you put it in the right place, it will work 24/7. That's awesome, that's great, but it will not have constant output, meaning the output, let's say you have a wind farm, and that wind farm is like, let's say 1 gigawatt, does not mean it's going to give 1 gigawatt continuously. It will give like, sometimes it could dip to like, 600, and sometimes it can go as high as like 1200. It does happen. It's one of those things. That's why like we are trying to make as bigger as wind turbine as possible. That kind of stabilizes the unbalance in the system. But you still need energy storage, but compared to solar, you need much smaller. So meaning if your solar needs, let's say for a nation, 10 gigawatt hour kind of capacity, it's still very little, but just for the number sake, you will need only, let's say, 3 gigawatt hour sake. So from that energy availability point of view, that's one good thing about it. So, but it does have one serious consequences, meaning it requires huge capital to start. Meaning solar, I can think of, again, right now I can't do it, but I can think about it, and I can make money hopefully in the future where I actually do it, and many people have actually done it. It's one of those things that I know for a fact that if you look around, or you may know people who have already done it, it's one of those things that people are doing it. But when it comes to wind, countries on top of countries who have more than enough coastal area where to justify it, they're not doing it simply because it's idiotically expensive. It's awesome that there is one giant turbine that can go upwards of 12 megawatt, but it's idiotically expensive. So capital requirement is like almost, it can bankrupt a country if not done properly. So let that sink in. It is seriously capital intensive. So that's its limiting factor. And not to mention that 24/7 is there, but it's not like, constant energy production. And sometimes worst case scenario, it could actually stop. So that does happen. Then what about hydro? Now, hydro is thankfully one of those technologies that we have been using for long enough, and ironically, it's one of the first green technology that we truly utilized. It works. It's one of those things that it works. It works as a base load. We know how to use it. We know how to deploy this sort of system. Everything about it is awesome, except location, meaning it's very picky where you can put it. And on top of that, it does not have enough scalability, meaning and stability also, because it does destroy the ecosystem. And not to mention, because of global warming that we have already caused, the glaciers are shrinking and snowfalls are shrinking, meaning instead of having a constant dribble of water that you can charge up in your reservoir, we have nothing, flash flooding, and it destroys your dam. So it's a serious risk right now, because instead of having snowfall, we are having ludicrously higher rainfall. And not to mention, the rainfall are no longer timed, meaning there is no longer a season where rain is going to happen. It's like, I feel like it. So that creates an issue for dam, meaning they have to drain the reservoir willingly, knowingly, and hoping that rain season happens properly and it refills it. Otherwise, if it's already close to full, they have to open the gates. And so, meaning dams are almost at their last leg. So I do not expect to see dams becoming a big thing for next 100 years. And that's why you do not see a lot of people talking about dams. And not to mention, there is a issue of scale, meaning if every state, let's say there is a dam starting from Himalayas, upper regions of India, and starts to go down, let's say go down through like 3 or 4 states, and if everybody started to make dam, the last states will be like, dude, we don't have water here. So that's a very serious issue. It's like water, it creates a water shortage. So it's not something that you can just, don't think about it unless you are China. Then you can be like, yeah, I'm gonna put 12 gigawatt here. It's like, bro, you're creating a reservoir that is a bit too huge, meaning if for any reason your dam cracks, the flooding it will cause will bitch slap every single flooding that has ever happened in the human history. And not to mention, you also have ludicrously high population density. So yeah, death toll will be like, damn. Yeah, pun intended. So these are the 3 tools that we have that works on large enough scale, meaning if I say gigawatt, you can just phone up someone and get this puppy working. So how can we use all 3? That's the problem. None of them single-handedly can do anything. But if you mix all these 3 utilizing HVDC link, because without it, you cannot transfer power long enough, far enough without loss, low loss. So we need high voltage DC links. Without it, we simply cannot connect all these 3 things. And you need grid scale battery, because these 3 things can have different varying output for different reason at different times. For example, your dams could be shutting down for maintenance. You have to shut it down. Your wind can be like, you know what, I don't feel like it. It had happened to Europe, where their like wind output was not as much as they were expecting, and that's why gas prices were like affecting their electricity prices as much it was, because it like wind was just not blowing. Solar, again, solar is kind of more predictable, but it still has it's like good days and bad days. So you still need a grid scale battery. That's the current option we have. So what about the magic bullet technologies? Magic bullet technology number 1, fusion. Now, fusion is this, it's here, it's real. In terms of physics, it's real. And it's almost perfect solution, meaning it does not have any byproducts, as in the amount of byproduct it will create. It will create some, it's not zero, it will create some, but it's like per gigawatt hour that is producing, it's almost negligible. Now, biggest radioactive waste it will create is the reactor walls, basically, because those are in high neutron density environment. They will become radioactive over time, and they will also degrade. So over time, you have to keep replacing them. Now, nobody actually knows how long they will last, because again, there is no reactor that works 24/7 into 10 years or 12 years. So we can know like how long does a plate last. But assuming, let's say they last for, let's say 10 years, every 10 years you have to, reskin, quote unquote, the interior of the reactors. And that becomes a very radioactive waste that you have to deal very seriously. Now, that's awesome aspect of it, that it has very little waste product you have to deal with. The radioactive tritium it will create, it will calm down very reliably, very quickly. So that's also not an issue. But it also has 24/7 power output, meaning it does not give a damn about water. It does not give a damn about rain. It does not give a damn about sunshine. It's like, I got this 24/7. That's awesome. And it also has throttle ability. Right now, we do not throttle our power plant simply because of economic reason. But if we needed to, let's say everybody started to build giant puppies of these, we can throttle it. That's awesome. Meaning, if your grid starts to relax, meaning let's say nighttime, your power requirement goes down, you can throttle this puppy down. It's like, hey, relax, just chill. And sometimes you may need to overproduce. So unless reactor is running at like absolute 100%, you can even throttle it up momentarily. So you don't even need peaker plant. So it does have throttle if done correctly. So that's also awesome. And it can clean earth without any issue. Like we have added way too much carbon dioxide. Now you must be thinking, why don't we remove it? Yes, we can try to remove it, and we have built tools to remove carbon dioxide from the atmosphere. Why don't we use it? Because in order to use those tools, we have to consume energy, and we do not have any clean source of energy. So trying to do that is basically replacing one carbon dioxide with another carbon dioxide. That's why we don't do it. We are developing tools like carbon sequestration tool. We are developing like there is no tomorrow. We have many of the technologies that actually work, but they require a power source that is clean. This is the only power source that would be absolutely clean, and it will not create like, oh, we are creating solving this problem by creating another problem. So that's one good thing. It can actually clean, and it can sort almost humanity's every single problem. So that's amazing aspect of it. Only real bad side of it, even though it has been working out for like 50 years, past 50 years people have been working on it, it's not real. It's like basically, even though China is like amazing PR department where they claim the reactor sun reactor, and I got so many comments, it's like China has made sun. No, they just named the reactor sun reactor. It's one of those things. They only work in seconds. We need a reactor that works in decades, not seconds. So reality is, it does not work. And right now they do have power factor is very low, meaning you put 1 megawatt in, it barely gives you 700 kilowatt. So it's not enough, basically 0.7 megawatt. It has to exceed input power by at least a factor of 100, at least 100. And first I did not know why it has power factor has to be so high. But the reality is, every time people are telling us we put power in and we got almost 0.7 out, they are only talking about the gyrotron power, basically the energy device that is used to heat this puppy up. That's awesome, but yes, there is cooling circuit going around, and that's cryogenic, absolute zero kind of cooling. So that is idiotically energy intensive. What about those energy? Compressors, cooling, auxiliary computers, all that jazz. Once you start to add all those things, meaning real world things, then you'll be like, yeah, it does not, it needs to be at least 200 or 300x more power than the input. Only then it starts to make it break even factor, which you call it. So to break even, it does not need to be like, okay, we put 1 megawatt, it gives out 2 megawatt, that's good enough. No, it has to be hundreds of x. So otherwise it will simply not work. And even if, assuming somebody cracks it, like some MIT design cracks it or some ITER design cracks it, it works in real life, then it creates another problem. It's very high tech, meaning it is not something that you can expect to see everywhere in the planet. There are 200 countries in this planet, only few countries could even attempt it. Barely 2 or 3 countries will be able to actually build it, because it's A, too expensive, B, requires too many expertise in too many fields in one central location. Like, to give you example, every Tom, Dick and Harry among us consumes microchips. Here's the deal, how many of us have access to fabrication lab in our country? There are only few, Taiwan including. So that's the harsh reality of it. If this sort of technology actually works, it's not simple enough where you're like, tada, nuclear reactor is simple, normal fission reactor. This is complex beyond belief. So that's another aspect. Even if somehow there is a blueprint that works, other countries cannot attempt it. And the hype is very serious around it. So the cost is another aspect of it. Even if you somehow have the location and expertise, can you actually afford it? And we have already spent billions on it. Like USA alone has spent around 30 billion on it, and other countries like France, UK, India, China, all that. If you combine all the money required, it's billions of dollars, like hundreds of billions of dollars. So a lot of money has been spent. And the best estimate, that is like ludicrously optimistic, hoping for some magical breakthrough, is 2030. And that's assuming things go well, which at this point in time I'm too tired of. And not to mention, there at that point in time, if best case scenario, 1 or 2 reactor will work and it will be barely producing any power, meaning you will be spending billions of dollars to get a power plant that barely produces 50 megawatts, if lucky. So that's the real aspect of it. It's not ready, it's not here, it's not real. So question becomes, should we spend billions of dollars we have been spending on this? Now, that may sound like, yeah, because again, if it does work, it will solve all our problems. But problem is, we are running out of time. We no longer have the, it's 40 years away. That was like 40 years ago. So we do no longer have that next 40 years away. We are running out of time. And the billions of dollars that we have already spent, if that was money spent on solar, like with the, religious orders, we have to spend on solar, we will have made solar so cheap that at this point in time, many times people say, oh, we do not have enough surface area. We just have to put it on rooftops, not anywhere else. Like making a farm does make financial sense, but from a practical point of view, it's much more effective if you cover every household with solar. And at that point in time, you will find we have more than enough surface area. And not to mention, we do not have to worry about land wastage, simply because those land has already in use. For example, large parking lots for large buildings, railway stations, things of this nature, which are already in use. In those sort of scenarios, if you cover them with solar panels, rooftop, which we already know, we are already doing it small scale. In large scale, we already have enough surface area right now to take care of entirety of planet's energy need. So if billions of dollars has been burnt, that's enough that you can build like HVDC link between countries, so you can do not even have to worry about grid storage. You'll like you do it during daytime I'm taking energy from let's say northern side of it, and during night I'm taking from the southern side of it. That's how awesome that money is. But we are spending it on this, which best case scenario is like 30 years away, 40 years away, 50 years away. I'm getting too old for this. That was one magical bullet. Another magical bullet solution is space solar. Now, it's also almost perfect solution, and it does have one benefit. It does have total heat output less. Now, like, how the heck that's possible? Well, even if you have a magical fuel reactor, which does work, assuming you are burning fuel, as in like fusing the fuel, you will be in a scenario where you're releasing all the energy trapped into that. That's awesome, but here's the deal: you will never be able to convert 100% of it into electricity. So what happens to the rest 70% of heat that was created? Waste heat. So planet will start to heat up because again you're dumping heat into it. So that's an issue. Now, what about solar space? The reactor part happened on the sun. You don't have to worry about it. Only good photons are coming here. And conversion inefficiency, meaning let's say only 30% or 40% of the solar light was converted into electricity. What about that remaining, majority percent? That will become heat in space, not on planet Earth. So meaning the total heat that Earth has to dissipate does not go up that much. And even if you are pumping, let's say 1 gigawatt energy, conversion efficiency from microwave to electricity is much more good 90 plus kind of percentage rather than 30% of normal thermal cycle. So that's why it does have one benefit. If you start to do gigawatts of it, it will not add gigawatts of waste heat, which fusion will add. So it is one good scenario of that. And it also provides enough power that you can clean the oceans. Basically, you can just drain carbon dioxide from the atmosphere and make it into dry ice and then bury it under the ocean and don't even think about it. Or even better, you can take like enough carbon dioxide and make it into hydrocarbon, then bury it exactly back in the oil wells where we found it. So that can be done. It has enough oomph to do that. And a lot of countries are looking very seriously into it. And that's why I'm doubtful about basically fusion project, because again, USA is spending boatload of money, Japan is spending boatload of money, UK is spending boatload of money. And all these three are like, you know what, let's look into space solar. I'm like, why? Why? Because again, even attempting this is multi-billion-dollar investment. Why the heck you are attempting it? As in, like, Japan is seriously designing it, and next few years they will have a prototype. Again, small scale, but prototype. Like, they are very serious about this. And China is also looking seriously into the UK have a project there, like, working, and I'm pretty sure they are like on early design phases. And NASA just reopened their project, which they were trying in 1970s. So why the heck these smart people are doing it? That's why I'm reasonably sure that fusion is not happening. Because otherwise, these people will not look into it, because fusion does have the benefit. Is like it's much simpler. It does have waste heat, but again, we have to remove enough carbon dioxide from the atmosphere to offset that. But it's doable compared to space solar. Now, what changed in recent year where space solar we went from 1970s to now? Well, large reusable rocket is a must. If you do not have large reusable rocket, NASA was attempting this in 1970 simply because they thought that space shuttle would be the magical thing they were thinking. At around 50 launches a year, each launch carrying 20 tons. Then their mathematics was like still expensive, but it was like, we could do it, we could brute force it. But now their realization was like, we still need something much more cheaper, something much more capable. If Starship is true, if it works intended, as in like it can carry more than 50 tons to low Earth orbit, and it can do it cheaply enough, and it can do it at least 50 to 60 times a year, then we are golden. Then we can actually build something like this. Because prototype Japan can do, prototype UK can do, but when you're talking about like big boys, that is like powering a nation, at that point in time you have to have a basically big ass rocket. Without that big ass rocket, it's not gonna work. Now another creates a issue only some country can afford. Is back to this magic bullet problem. And you may be like, how the heck it will remain in the same place? It won't. It cannot be in geostationary, because while you can put it in geostationary, it does create an issue that for a few months in equinox kind of time, it does go basically the power satellite will go through the Earth's shadow, so it will not provide power for around 70 minutes. You cannot have national power going away for 70 minutes. So you have to use what we call geosynchronous orbit, not stationary, synchronous. So from Earth's point of view, the satellite will look like it's like making an 8-figure. The cone will remain the same. Like if you have a big enough dish, the cone will remain the same, but it will not be exactly static. Benefit, it can angle can be in such a way that it misses Earth's shadow all the time. It will never go into shadow, so it can achieve 24/7 power, which is needed for a nation. So these are the two magical solutions that people are hoping for spending money on. Now, this decision basically to spend money on either space solar or fusion, it's a very impactful decision because A, we do not have infinite money, B, we are running out of time. So failed projects have very serious harmful effects on all of the society, meaning if a French company burns money, if scammers of USA starts to actually trick people into a solar roadway is the amazing future and they burn millions of dollars, it does have consequences, meaning logical projects will get cancelled. For example, how about we solar panels where it matters? A clean place where it does not get have car running over them, like parking spots. Those sort of place makes boatload of money. Like people are doing that. But again, imagine anybody investing money into this. They will be burnt so badly they will never touch solar again. And again, I cannot blame them. But that's the whole point. This sort of stupid project should not have like the amount of money burnt. Like China burnt it, Germany also tried it. French built this damn thing. USA is burning money like there is, and I'm talking energy division ministry burnt money into this. It's like how dumb you have to be, an energy minister. It's like how the heck that happened. But again, it happened, and it creates what we call erodes public confidence, meaning if 5 or 6 of this sort of solar projects will happen, people will give up on solar. It's like, dude, no, solar is just a scam. And I can't blame them. If you have seen, like, your local county spent millions of dollars on it and they have nothing to show for it, you will be pissed. And it also reduces funding. So that is why we cannot just have, oh, we tried hundreds of things. No, we have to be very mindful on what we try now. We are running out of time. And why you may be like, I am always against hydrogen because it's one of the worst fuel ever. Like, how the heck we know? Well, we have tried it. We have tried it as early as 1970 when oil embargo hit USA and like hurt it badly. They actually tried it, making cars like as early as Audi, BMW, and other car companies also tried it, and they actually had full of working prototypes. And reality is, hydrogen does not have enough energy. It's like if you want to sell it to someone, you will say, hey, hydrogen has 100 plus megajoule per kilogram. That's absolutely true. That's how people get tricked into it. But here's the deal. Ask them how much megajoule this puppy has per liter, meaning volume. At that point in time, you will find, if you will be lucky, as in like you're carrying liquid hydrogen, you will have only 8 megajoules. That's very little. How little? Diesel can easily achieve 35 or even higher than that. So meaning you have to use diesel at around 25% efficiency or even a bit more than that, then you can bitch slap hydrogen. And to even compete at that point in time, hydrogen has to be 100% efficient, which good luck. No fuel cell is that much. And not to mention diesels in real world, in real market, companies will market you as like 35%. Real world target is 30%, like we have. So we already have more than enough energy on that. So why the heck companies like Hyundai, Toyota, they are still burning money away on hydrogen system? Sunken cost fallacy. They spent billions of dollars in it thinking it will work, because be mindful, that point in time lithium ion was not a thing, and lithium ion and hydrogen are more or less same kind of energy carrying capacity. And not to mention, electric car is much simpler, fewer parts, meaning mass production of it is far more achievable. So that's why sunken cost fallacy can like literally create a salesman desperate, and they will be like, you know what, this has 130 or 40 megajoule per kilogram. It happens. This sort of bad product hurts countries. It has hurt them in past, so it is not something new. It is brutal. And bad moves is not only like, harmful to basically our finances, also harmful to the planet. For example, there is a carbon footprint of every material, every mineral, every manufacturing process we do. Very little, but it's there. So for example, this puppy consumed, let's say 200 kilograms of carbon dioxide. This also did the same, 200 kilograms of carbon dioxide. But here's the deal, it did not add any further. It's like, hey, we are reducing carbon dioxide simply because we are not burning more fuel, we are providing the electricity. And overall life cycle of a solar panel that's working in good place, it's net positive, meaning it would have been better to release that carbon dioxide to make them, because there is nothing else right now in deployment that will release like same amount of carbon dioxide and give same amount of power. This will give far more power. So that's why we wanted to do it. But again, imagine wasting that on this. The carbon dioxide is in the atmosphere, you just don't even have the electricity for it. So that's why we have to be very mindful about that, because we can harm the planet without even thinking about it. That's why I like started with electric cars being good, hydrogen really bad, electric bit better, but biofuel was the perfect. But then I let go of biofuel because we do not have enough farming land. But recently I just realized I was looking in the wrong place. The right place is C. If we have C weed biofuel farming, it takes care of all our problem without creating new mess of like mining cobalt, mining nickel, mining lithium. It does not create that, and we already have enough manufacturing ability, enough everything built that we do not have to throw them away. So that also reduces carbon footprint without adding new carbon footprint, and also cleans the ocean as a benefit. So we have to be very mindful. Do we spend money on magical solutions, or do we spend money on things that are imperfect, but it's here, it's real? So it will have very serious impact. These are very impactful decisions that everybody of us has to take. Basically, wisdom is a must for future. If we do stupid things, consequences would be brutal. So this was my presentation on basically moonshot projects versus current tech. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.